Hello everyone. So today I'm going to be guiding you through how we achieve reproducible HCP coverage using 2D techniques by using our SpotMap 2D software. Now, one of the very common complaints outside of the difficulty of the manual handling of this technique is difficulty in data analysis and being able to get reliable inter-operator, inter-site coverage scores for different antibodies. And we've introduced a number of features within our SpotMap software to try and reduce the pain caused in these particular areas. So I'm going to go through the software very quickly with this demo set of images, which aren't the greatest, but just highlight how we've tried our best within the software to reduce these to overall make your data quality better, make your data more reproducible, make the software easier to use and reduce interoperator variability due to subjectivity of the technique, and basically what we've done on the software side to try and make your life as easy as possible when performing this. So first thing I'm going to do is I've obviously got my gel and blot pair here. So 2D gel and 2D Western blot rather than a 2D Dige or dive technique. No multiplex, the classic gel versus blot pair. The first thing I'm going to do is simply align my images. So alignment, and in particular our pixel level alignment, is one of the features that we've got to try and reduce inter-operator variability. Now, I'm going to align my blot to my gel, so I'll select my gel as my alignment target. We have automatic alignment, which again is designed to be a non-biased method of aligning images. Now, it's not going to work very well with this demo pair, because if we just have a look at our images, you can see that there are many spots on our gel, and there are not many spots on our blot. So we can already tell going in this is going to be quite a low coverage percentage score at the end of this. And in situations where there are few spots, there are much fewer sections for the images to align onto each other. There are very few anchors. You know, if most of your image looks like this grey, what are we going to kind of latch onto to ensure accurate alignment? But the idea behind the automatic alignment, and if you've got greater coverage images, it will work better than this, is that you remove the human component of manual alignment. And again, pixel level alignment rather than aligning based on spots does much better within images like this where you have low coverage and where you're not just trying to match spots up to each other, but where you're trying to align images to each other, which sometimes may include blank space rather than areas with spots in. So I'm going to try the automatic alignment, and I know I've used these images before. I know it's not going to work particularly well. Now it's worked slightly well. If I just kind of pop this image out here, you can see this motif at the bottom is something that is maintained between two different images. So you can see here are the spots on this blot image, and here are the spots on this gel image that want to be aligned with each other. We can see that, yeah, the alignment hasn't worked there. So what I'm going to do is I'm going to get rid of that alignment. I'm just going to change the contrast on this image to make it brighter within the alignment window. So the alignment window, as you can see there, copies the contrast from the images that you've set. So all of the image setup that you've done prior to this carries through to make this step easier. Now, because I've worked with these images, I know the alignment's very tricky. But what I'm going to do is I'm just going to do a 2-point alignment. So I'm going to grab that motif that we spotted before, these green spots here, and I'm going to drag them over onto our pink spots here. And I'm going to show this as an aligned image. You can see it here. I'm going to drag this probably across to here. And then I'm just going to come to the top of the image and align it up here. What am I looking for? Let's just turn the transition back on. I think we may have already aligned. There we go. So it's probably going to be really hard to see, but we can see on the green level, these sections just drop in to these spots here. But I had actually already aligned. By aligning the 2 points at the bottom, I had aligned the section at the top that I was going to look at. So if I just turn this pause off here, you can see as we fade out, we see this section here. And we just, update the alignment there. Now we can see they're flashing in place. I've got a longer video about the alignment process, how we go into it. That's going to be much more useful if you're doing this. But I want to keep this as an overview of features that we've introduced to make this technique easier for users to get right, rather than going in depth into everything. So that's kind of the first level of reproducibility, is if you can consistently use the automatic alignment feature, you're going to save a ton of time, but you're also going to remove a lot of the human subjectivity of alignment, of deciding where spots need to go. Another layer of automation that again provides greater reduced interoperator variability and greater accuracy in your results and consistency in your results is automatic spot detection. Now, I'm just going to define an area here. If you have a very standardized process, you're always using the same size gels, you're always using the same capture settings, you can be really precise about the size of the region that you select from your gel or block, and the detection parameters that you want to use for every single image. Now, you can actually build this into a protocol if you want. So you could say on site, peak sensitivity is always 502, smoothing is always 1. We're always going to have it as, include only new spots, of which each spot is new. You can define that and have that as a standard constant. So you've got visibility into how the automatic spot detection is performed. And then obviously click on the detect spots and observe the spots be detected. And then you can start going ahead and, marking those as present on both images. Then start marking some as absent and performing the whole thing. So again, I've got a separate video on how do we work out coverage, how do we split it into low molecular weight, high molecular weight, low PI, high PI, things like that. I'm not going to go into great detail with that in this video, but again, if you can reliably, consistently use the automatic spot detection, that's going to give you much more consistency between your results and give you much more rigorous data. We can see that within our SpotMap software, we give you an exact coverage percentage. We don't give you a range. We don't have the concept of something being not a spot, not present or not absent, this kind of gray zone that maybe other software has. We give you a definitive score based on the work that you've done. So we move forward into another another measure of reliability and reproducibility is the fact that we propagate the spot map, this map of all spots, this 100% network or population of spots within an image to every image. So I'm only using 2 here, but SpotMap can support as many images open at once as your computer can handle. We propagate the same spot map to everything. All the changes are reflected across the same spot map across everything, so you've always got the same template to work to on each of your images, which again is really important for having this baseline to work against, to again make sure that you're performing things the right way on every single image in a consistent manner, so your data is consistent and therefore reliable. Moving forward, another feature that we have again to raise the bar on consistency, data consistency, whilst also offering the ability to work through your data much quicker than kind of manual techniques, is the idea of filtering. Now, you may on site say, and this is how we get rid of the idea of an unsure spot or an unpresent spot, is we allow users to set a cutoff for what they consider to be a positive result or a negative result, aka did the antibody bind or not? Is it specific binding or is it non-specific binding? Is it background or not? That kind of thing. Now, we do feature automatic background removal within the software, which the user has a choice of. So they've got lowest on boundary or average on boundary. The difference is lowest on boundary draws a pixel outside of all the spots and picks the lowest intensity value. Average averages 1 pixel outside the box for a spot and then calls that the background. So it's just different measures for the same processing. So filters allow you to say, right, for all of my gels on site, all of my blots, everything, I'm going to say that anything less than this intensity is a negative result. So what I can do is I can use the filter tool and select and say, right, anything with a peak height lower than this spot, so I can get the value from that spot automatically. Anything lower than that, I'm going to mark as a negative, so it's not positive. And then I could say anything that is greater than that, I'm going to mark as positive. So I can select those and mark as positive. So you can set internally what is your baseline, what is your acceptance criteria, and you can have that for every single blot or gel that you're using. Again, it relies on your imaging being very consistent, but you could even have, standard proteins that you include at every run to be able to calibrate this very accurately to say, right, well, if this spot is present or absent, that's what we're going to set as the standard, something like that. So we've got all of these different tools to really increase the reproducibility of 2D page-based whole cell protein coverage analysis and really get that reliability both between operators, between sites if you're doing tech transfer, and just generally try and remove that pain point as much as possible. So you can streamline your data analysis, you can streamline your ELISA development, your HCP antibody development. You can streamline the whole process and get really rigorous data in less time and eliminate gel to gel and user to user variability using all the tools that we've got built into our SpotMap 2D software. But don't just take my word for it. Please head on over to our website, check out the links in the description below, go and get a free trial of our SpotMap 2D software. Works with pretty much any scanner, pretty much any image format, including formats from other analysis software, so you can try it out head to head. Try it out with your own images. There's no limits on the free trial. It's just a 7-day free trial, so you can try as many different permutations of the tools and of image types and things that you want before making a decision. But if you do need help making a decision or you do need help using any of the tools within the software, as always, please feel free to reach out to us. We'll help to support you during the trial, during the demo, and hopefully you'll see the benefit of using SpotMap on your site.